Hello there. In this video we're going to be solving systems using the method of elimination. In a previous video we looked at a different method. That one was called substitution. So both of them can be used to solve different systems. Sometimes one is going to be better than the other, just depends on the system you're given. So the idea behind elimination is that you want to eliminate one of the variables, because let's say we just had this equation here, and if I was able to eliminate this 2x, then I'd only have minus 3y equals 15. It's a lot easier of an equation. So that's the idea. You're going to eliminate one of the variables. And the way we're going to do that, we're going to use a second equation to eliminate something in the other equation. So if I took these two equations the way they stand now, and I added these, just like how you'd normally add things, like if you had 12 plus 3, you could add like that. You got to add up in the column. They all have to be lined up nice, so you'd get 5, and then this 1 would come down, you'd get 15. So we're going to do the same thing. We got to make sure they're lined up nicely in their columns. So we're going to see some examples where they're not going to be lined up nicely. In this case though, I have x's together, y's together, equal sign, and then just our constant term together. So if I add this up in the first one there, 2x plus 5x, that's going to give me 7x. And then adding these ones up, negative 3y plus 3y, that's equal to 0 y's. So that's why this is going to work. It's because it's going to eliminate a variable. Then we have equals, and then 15 plus 27, that's going to give us 42. So now I have this much simpler equation. I have 7x equals 42. And then to solve that, I could just divide both sides by a 7. So these 7's will cancel, and I get x is equal to 42 divided by 7 is 6. So now I know what x is equal to, but I don't know what y is equal to. So I need to take this and I need to substitute that either into equation 1 or into equation 2. So we're going to sub it into equation 1 or equation 2, and I just have written whichever is easier. So when I look at these two equations, to me equation 2 looks a lot more difficult. So I'm going to take 6 and I'm going to put it into equation 1. So I'm just going to do that right up over here. So I'm going to write down equation 1. It was 2x minus 3y equals 15. But I knew that x was equal to a 6. So it's going to be 2 times a 6 minus 3 times y equals 15. And then 2 times 6 in the front there is 12. And the rest can just stay the same. And then we want to isolate this y. So I will subtract 12 from both sides. These 12's will cancel. So we only have minus 3y, and then equals 15 minus 12, that's 3. And then we'll divide by negative 3 on both sides so that these negative 3's will cancel. So we get y equals, and then it's going to be negative, and 3 divided by 3 is 1. So I know that x is equal to 6 and y is equal to negative 1. So our answer, written as a point, is 6 and negative 1. So that first one was a little bit easier just because they were already lined up all nicely, and these terms were the same, that when we added them, they actually went away. So this next one, it's not going to be as nice, it's just going to be a little different. So it says both equations must be in the same form, and usually we like to write it ax plus by equals c. A, b, and c will just be numbers. So with this one, we have 3x plus 2y equals 12. So that's like the ax plus by equals c. But this one, it's all on one side. We don't have this 12 over here. So we need to move that 12 over. So I'm going to do that over here to the right. So I'm going to rewrite my first one. It was 3x plus 2y equals 12. And then with the second equation, I'm going to only move over that positive 12. So I'm going to subtract 12 and subtract 12. And then these 12's will cancel out there. So I have 3x minus 6y equals, and then the negative 12 is now on the other side. So now everything's lined up nicely. I have x's, y's, equal sign, and then my number. And then what I want to do, I want to try to somehow eliminate either x's or y's. So if I were to try to add these, if I went 3 plus 3, that would give me 6x, so nothing eliminated. If I added these, plus 2 minus 6y, that'd be minus 4y, so nothing eliminated there. But if I took 3x and I subtract 3x, then these will eliminate. So that's what I'm going to do. I'm actually going to subtract instead of add. You just want to do whichever one is going to work. So 3x minus 3x is 0x, and then I'm going to have 2y minus 6y, so that's actually 2y plus 6y, because 2 negatives is a plus, so that's going to give me 8y, and then I have equals, and then we got 12 minus 12, so again, that 2 negatives are going to give us a plus, so 12 plus 12 is going to be 24. So my equation that I get out is just 8y equals 24. So we can divide both sides by an 8. The 8's will cancel, and we get y is equal to 24 divided by 8 is 3. And then again, I know now what y is, but I don't know what x is. So I'm going to have to take that and sub it into either equation 1. So let's call this one equation 1. Or I could put it into equation 2. And again, you just want to pick whichever one is easier. So to me, it looks like this one might be a little bit easier. The numbers are slightly smaller, so we'll use that one. So I'm going to do that just up over here. So I have 3x plus 2y equals 12, and then the y is going to change. So it's 3 times x plus 2 times y, but y we found was a 3. And then we can simplify and solve this. So it's 3x plus, and then 2 times 3 is 6. And then we got to get rid of that 6. So we will subtract 6. My 6's will cancel. And so I just have a 3x on the side equals, on the other side, 12 minus 6 is 6. And then lastly, divide both sides by a 3. These 3's will cancel. And so I get out from this, I have x equals, and then 6 divided by 3 is a 2. So our final answer, we got x was 2 and y is 3. So our answer is 2 and 3. So this example tried to show us that we can't just subtract or add them the way they are. We may have to maybe move a term over to the other side so that we have x's lined up, y's equal, and then constant term. The next example is going to show us again something new. So with this one it says if the coefficients do not match up, we need to write an equivalent equation to get them to eliminate. So we have x's, we have y's equal, and then our number, but we don't have the same number in front so that we could add or subtract and they cancel out. Same with these ones, they're both not 4's. Like on this one, they're both 3's, so if I subtract, it'll cancel out. And with this one, they were both 3's, so when I added them, they canceled out. So this one we're going to have to change, we're going to have to do something to get them to be the same number in front. So if this one has a 3 with the x, this one there's no number there, so there's really just like a hidden 1. But if I wanted to get that to be a 3, I would have to multiply this by something. I would have to multiply by 3. But you have to multiply every single term by 3. So you got to multiply this one, the other term, and this term. All of them have to get multiplied by 3. So I'm just going to do that and write it over here on the right. So our first equation will stay the same. 3x minus 4y is equal to 27. And then our second one, we multiply everything by 3. So 3 times 1 is 3. Then we had x. And then we're going to have 3 times 3. So that is a 9. And then we had y. And then equals. And then with the last one, 3 times negative 4. That is negative 12. So now everything is lined up nicely. And these numbers are the same. So if I were to subtract these equations, then they are going to eliminate. So 3x minus 3x is 0 x's. And then I have minus 4y minus a 9y. So that's going to be negative 13y. And then equals. And then we have lastly 27 minus 12. So that's actually 27 plus 12. So we're going to get 39. So what we have left, if we get rid of that 0x in front, is this right here. And then we can divide on both sides by negative 13 to get those negative 13's to cancel up front. So what we have left over is y equals, and then 39 divided by negative 13, it's going to be negative, and 39 divided by 13 is 3. So we're going to take this, and again, we're going to have to substitute it back into one of these equations. So we can put it into equation 1, or we could put it into our original equation 2. And again, whichever one you pick, try to pick the easier one. So when I look at these two, this one's got a 27. It's way bigger than this one. So I'm going to put it into equation 2. So I'm just going to do that right over here. So our original equation was x plus 3y equals negative 4. and then I'm going to change the y. The y changes into a -3 because that's what we found. And then we'll simplify that. So we got x, and then we have a +3 times a -3, so that is -9, and equals -4. And then we want to get the x by itself, so we got to get rid of this -9. So we're going to add 9, add 9. 9's will cancel, and we get x is equal to -4 plus 9, that is 5. So now we got x is 5, and before we had y is -3. So putting those together, our answer is 5 and -3. So in this example, this one showed us that sometimes we have to multiply by something in order to get the numbers to be the same. And then our example number 2, that one showed us that sometimes we have to move things over to the other side so that we have x's, y's, and our numbers. So example number 4 is going to have both of those things. We don't have the same number in front of our x's or our y's, and we also don't have our x's and our y's matched up. This needs to be a y, so I'm going to have to do some rearranging. So first what we're going to do is we're just going to rearrange so that we have our x's and our y's on one side and then the number on the other side. So this first one here is good. That's the form that we want. So 3x minus 2y equals 11. Just leave it as it is. But the second one, we're going to want to get this one over on this side and this one over on this side. And just a quick trick, rather than adding the opposite to move it over, if ever you move something across to the other side of the equation, the sign will change. So if this is negative, it's going to come over and it'll be positive. This one's positive. When it comes over, it's going to be negative. So we had 7x in front, and then the -3y, when I bring that to the left, it's now going to be positive 3y, and then equals, and then the positive 51, when I bring that onto the right side of the equation, it's now negative 51. So now everything is lined up nicely. We have our x's, our y's, equals, and then our number, but we don't have anything that we can eliminate. We need these to be the same, or we need these to be the same. And I can't multiply anything by 3 to get 7, or multiply anything by 2 to get a 3, unless I start using fractions, which I don't want to do. But what I could do is multiply this equation by something, and this equation by something, and then maybe get them to eliminate. So if I multiplied 2 by 3, I'd get 6, and if I multiplied 3 by 2, I'd get 6, and then these would be able to eliminate. So that's what I'm going to do. I'll multiply this equation by 3, and I'll multiply this equation by a 2. So I'm just going to slide this over a little bit so I got room on the right there. So we're going to multiply these. The first one, everything's going to get multiplied by 3, so it's going to be 3 times a 3, so that's going to give me 9x. Then I got 3 times a -2, so that's going to give me -6y, and then equals, and then 3 times 11, that is 33. And then our second equation, those all get multiplied by 2, so we're going to have 7 times 2, so that is 14x. Then 2 times a 3y, so that is equal to a 6y, and then equals, and then 2 times -51, that's going to be -102. So now I can either add or subtract these. So if I add them, I'm going to have -6y plus 6y, and then those will eliminate. So I'm going to add them. So we also have 9x plus 14x, so that is going to give me 23x. Then these ones are going to eliminate, so we're going to have 0y, we can just write that, and then equals, and then we have 33 plus -102, and that is equal to -69. So what we get out is 23x equals -69. Divide both sides by 23 so that these 23's can cancel. And we get x is equal to, it's going to be negative, and then 69 divided by 23 is 3. So again, we now know what x is, but we still need to find out what y is. So we're going to take this, x equals -3, and we're going to substitute it into equation 1. We can call this one equation 1, or into equation 2. And again, just pick the one that looks simpler. So to me, equation 1 looks simpler, so I'm going to pick that one. So I'm going to bring my work up and over, and I'm going to do that right here. So equation 1 was 3x minus 2y is equal to 11. So I'll change x equal to -3, so that goes in there. Then minus 2 times y equals 11. So 3 times -3 in front is -9. minus 2y equals 11. So we'll get rid of this negative 9. We will add 9, add 9. Our 9's will cancel. So we have negative 2y is equal to 11 plus 9 is 20. And then divide both sides by a negative 2. These negative 2's will cancel. So we get y is equal to 20 divided by negative 2 is negative 10. So we have y is equal to negative 10 and x was negative 3. So together we got negative 3 and negative 10. Remember, it goes x first and then y. So that example just showed us that sometimes we're going to need to rearrange, get them to look the same, x's, y's equals number, and then sometimes the numbers still aren't the same, so we have to also change the equation. Sometimes you got to alter both of them. Sometimes, like in previous examples, we just multiplied one equation by something. But in this case, we had to do both. And then we could get something to eliminate. So our last question that we're going to do is another word problem. Again, we've kind of seen one like this, so you should know how to do one like this. It says 2 student tickets and 6 adult tickets cost $102. 8 student tickets and 3 adult tickets cost $114. What is the price for a student ticket and then also for an adult ticket? So I'm going to first state what my variables are going to be. It's asking about the price for student ticket and adult ticket. So I'm going to let x equal the price of a student ticket and y equal the price of an adult ticket. So now that I've stated that, I can start to make my equations. So it said 2 student tickets and 6 adult tickets cost $102. So let's say a ticket was $10. If you had 2 student tickets, 2 times $10, it'd be $20. But I don't know how much the ticket is. But what I did there was I took the number, I had 2 of them, and I multiplied by how much they're worth. So I'm going to take 2 student tickets and I'll multiply by how much they're worth. Right now I'm describing it as x. And then for my adults, I had 6. So I'm going to have to add on the cost of the adult tickets, and I had 6 of them. I don't know how much they cost though, I'm using y. But when I add that up, that has to give me $102. And then the second line there, it said 8 student tickets and 3 adult tickets is going to cost $114. So it's pretty much the same thing. It's just changing the numbers. It was 8 student tickets plus 3 adult tickets, and that's going to add up to $114. So now I have my 2 equations. Now I can solve them using my elimination method. So they're already lined up nicely. X's, Y's, equal sign, just our number. But we don't have anything that's the same in front of our X's or our Y's. So I could take this and multiply by 4. That would give me an 8. Or I could take this one and multiply by 2, and that would give me a 6. You could do either of those options. Whichever one you want to pick, you'll still get the same answer. So I'm going to take this first one, and I'm going to multiply that one by 4. So when I do that, I'm just going to rewrite the bottom one. It's going to stay the same. So that's 8x plus 3y is equal to 114. Our other one, we're going to have to multiply by 4. So we got 4 times 2x. That's going to be 8x. Then we have 4 times 6y. So that's going to be plus 24y. Then equal sign. And then 4 times 102. That's going to be 408. And then what I'm going to do is I'm going to subtract these, because 8x subtract 8x is going to cancel out. That's going to give me 0x. And then I have 24y minus 3y. So that is just equal to 21y. And then we have equals. And then lastly, 408 subtract 114. That is equal to 294. So out of this, we have 21y equals 294. So to solve that, we can just divide both sides by a 21. 21's will cancel, and we get y is equal to, and then when we divide those, we get 14. And then again, we're going to take y is equal to 14, and we're going to substitute that into either equation 1 or into equation 2, whichever one is easier. And to me, it looks like equation 1 is a little easier. So I'm going to bring that up, and I'm going to do that right here. So equation 1 was 2x plus 6y equals 102. And then I'm going to change my y equal to 14. So this is 2x plus 6 times y, but y is 14, equals 102. So 2x we'll just rewrite. 6 times 14 is equal to 84. And then we're going to get rid of this 84, so we'll subtract 84, subtract 84. My 84's cancel, so I have left over just a 2x on the left. And then on the right, 102 subtract 84 is equal to 18. And then I can just take this, divide by 2, divide by 2. The 2's will cancel, and so we get out of this x is equal to a 9. So because this was a word problem, the answer we get, it has a little bit more of a meaning behind it. So x equals 9, remember at the top we said x was the price of a student ticket. So if x is 9, that tells me that the price of a student ticket is $9. And then if y is equal to 14, that was the price for a adult ticket, so the adult ticket price is $14. So let's just write that down here. And then lastly, we have our textbook questions. They're just down here at the bottom. So we're working on page 488.